Okay, so my voice is audible to all.
Yes, sir.
Okay. So in the last lecture, we have seen perpendicular axis theorem, parallel axis theorem. Now we are going to see some formulas for different types of sections for moment of inertia. Earlier we have seen the formulas regarding to centroid. Now we will see the formulas for moment of inertia. So the first figure is rectangle. First figure is a rectangle. Suppose now this is a rectangle. Now here somewhere the centroid of the rectangle is there. Now if you draw its axis, so this is y-axis which is passing through the centroid of this rectangle, and this is x-axis. These are also called as centroidal axis. This is y and this is x. Suppose the width of the rectangle is b. Width of the rectangle is b and the depth of the rectangle is d. So this is b is the width and d is the depth. Then formula is Ixx. Moment of inertia about x-axis and moment of inertia about y-axis. Okay, now this about x-axis. Now if you see this x-axis is cutting the dimension d. x-axis कुणाला छेदून चाललाय तर d ला छेदून चाललाय म्हणजे क्यूब कुणाचा करायचा
D चा.
d चा करायचा. So your formula will be here d cube by 12. Okay, and this y-axis is cutting the dimension b. Okay, so it is v cube by 12. This is the formula for moment of inertia of the rectangle about centroidal axis. Okay, here this is the centroid. These axes are passing through the centroid. We are talking about the moment of inertia about centroidal axis only. Okay, these are the formulas which we are going through are for the centroidal axis. Okay, so this is the formula. Now you tell me the rectangle is there. Okay, b and d its width and depth. What is x bar? So, what is x bar? What is x bar over here? It's just not x bar.
B by 2.
X bar is b by 2 and y bar
D by 2.
d by 2. Okay, and area here already आपण एकदा बघितलेलं ना b into. Okay, so these all formulas you need to remember for CG and MI. Already we have seen the formulas for the CG. Already we have seen the formulas for the CG. Now I am going to give you the formulas for MI, moment of inertia. Okay, so after rectangle we will take circle. So the next diagram is circle. Now this is the circle. This is having diameter d. This circle is having diameter is equal to d. This is the diameter of the circle, and this diameter is d. Now here somewhere at the center, the centroid of the circle is situated. In the case of circle, the center of the circle and the centroid are same. So here if I draw the x and y axis, this is our y axis and this horizontal axis is x axis. So this is y, here it is x. Now for circle, Ixx and Iyy. Now circle is a figure which is symmetric about any axis. Okay, so the formula for Ixx is pi by 64 d raised to 4, where d is the diameter of the circle, and for Iyy it is also same, pi by 64 d raised to 4. So this is the formula for the circle Ixx and Iyy. So it is same. Ixx and Iyy both are same. Now you tell me for the circle, what is x bar? What is x bar for the circle?
R.
R. Okay, R. And what is y bar?
R.
Y bar is also R. And what is the area of the circle?
Pi r
Pi
square.
r square. Or pi by 4 d square. It is also area. Instead of r, if you put here d by 2, then it will be pi by 4 d square. So this is about circle. This is about circle. Now triangle. Next figure is triangle. Now this is a triangle which is having base B and height h. Base B and height h. The centroid of the triangle may be situated somewhere here. Okay. Then x-axis and y-axis we will draw. So this is our y-axis. Then this is x-axis. These are x and y axis. Here is the centroid. So here is the centroid. This is y, x, base of the triangle is B, and this height of the triangle is h. Height of this triangle is h. So the formula for the triangle IXX is equal to, it is BH cube by 36 and IYY is equal to HB cube by 48. HB cube by 48. This is for the triangle. Okay, for triangle, I think all the formulas we have seen already. X bar, you know, in this case, if your width is B, then it is B by 2 and Y bar is equal to H by 3. So now the next diagram is semicircle. The moment of inertia for semicircle. Close the door. So now if you see, this is a semicircle. Semicircle. Now the center of the semicircle is this point. Okay. But the centroid of the semicircle is not the same. Centroid and center are different in the case of semicircle, while it is same in the case of circle. So now here we will draw x and y axis again. This is our y axis. And again we will draw x axis. Okay. So here this is y, this is x, and now this is the base. Base is nothing but the diameter of the semicircle. That's we have studied earlier also. Base of the semicircle is nothing but diameter of the semicircle. This is base, and suppose this diameter is d, capital D. Okay, suppose the diameter is d. Then what is the formula for Ixx and Iyy? Ixx and Iyy. Ixx and Iyy. Okay. So here you remember one thing, the axis which is parallel to base. इथं नीट बघा आता. हा x axis आहे, कुणाला parallel आहे, base ला parallel आहे. So listen my statement carefully. The axis which is parallel to base, its moment of inertia is 0.11 r raised to 4. Okay, its moment of inertia is 0.11 r raised to 4. कुणाचा? The axis which is parallel to base. Then it may be sometimes x-axis, it may be sometimes y-axis, depending upon the position of the semicircle, where the base of the semicircle is given, depending upon that. So you should remember it in this way. The base of the axis which is parallel to the base of the semicircle, that axis is having moment of inertia 0.11 r raised to 4. And the rest of the axis, the remaining, it is having pi by 8 r raised to 4. Pi by 8 r raised to 4. This is in the case of this type of semicircle. So here, can you tell me what is the value of x bar and y bar for this semicircle? This we have already seen. What is the value? Imagine करा ना, reference axis imagine करा तिथं. Reference axis कुठं असतं आपले? या corner पासून आपण draw करतो. Y axis, x axis. Those are our reference axis for x bar and y bar. So imagine where is the x bar, what is y bar, and what will be the distance?
X bar R, Y bar 4R by 3 pi.
Correct. X bar is equal to r, and y bar, for y bar, here at the base your x axis will be. So this is the distance your y bar. So from base it is 4r by 3 pi. So in the case of semicircle, base is very important. The next type of semicircle, if I draw the semicircle like this now, vertical base. Okay. Now this is also semicircle. Okay. And now here somewhere the centroid of the semicircle is situated. Now this horizontal axis is x-axis and the vertical axis is y-axis. So this is x-axis, this is y-axis, and base of the semicircle is nothing but the diameter. This is the base, and this base is nothing but it is d. Now Ixx and Iy. Now you tell me which axis is parallel to the base now, x or y?
Y.
Y.
Y-axis is parallel to base. Which axis is parallel to base? Y-axis is parallel to base. So here my Iyy will be 0.11 r raised to 4. And what is remaining? Ixx. It is pi by 8 r raised to 4. Okay. In this case, can you tell me what is the value of h bar and what is the value of y bar?
X bar
is
4R by 3 pi, Y bar is equal to R.
Y bar is equal to r. Area you already know, pi r square by 2. Okay. So this is the semicircle. Now we see about the, what we can say, quarter circle. Okay. So when you cut the semicircle into two parts, when you cut the circle into two parts, you will get semicircle. Okay. When you cut the semicircle into two parts, you will get quarter circle. So I will draw that now. Next diagram. So now this only this much of portion. Okay. So half portion of semicircle. Okay. So this is the quarter circle. Now the centroid of this figure may be situated somewhere here. May be situated somewhere here. And now x bar and y bar, if I draw the axis, this is the y axis. This is x axis. X and y. The formula for this figure is Ixx is equal to 0.055 r raised to 4 and Iyy, it is also 0.055 r raised to 4. Okay. And its area will be pi r square by 4. Its area is pi r square by 4. And you will see hollow circle also. Suppose this is a circle which is having diameter d. Now if I draw another circle,
Sir,
बोला.
the quarter circle's area 1/4 येणार ना pi r square.
हा मग तेच सांगितलं की मी pi r square by 4 म्हणून सांगितलं की.
हा सर ऐकत नव्हतं कनेक्ट
काय झालं?
रेंज गेली ती ऐकत नव्हतं ब्रेक.
हा हा. See, area of the circle is pi r square. Semicircle is the half part of the circle. That is why for semicircle area is pi r square by 2. And the quarter circle is the half part of the semicircle. So half part of semicircle म्हणजे semicircle चा area already pi r square by 2 आहे. त्याचा परत half घेतलं म्हणजे काय येणार? Pi r square by 4. So in this way you can remember the formula for the area. Okay, if you know the area of the circle, you can write down the formula for semicircle also, for quarter circle also. Just you need to divide it by 2 and 2. Okay, so now we will see the formula for hollow circle. Suppose now the internal diameter of the hollow circle is small d and the external diameter of the circle is capital D. Then in this case, if I locate here the centroid, this is somewhere centroid is located. Now we will draw x and y axis, both axes. So this is x axis and this is y axis. X then y. Now you know that internal diameter is small d. See here, this circle is having diameter small d. Okay, and this circle is having diameter capital D, external diameter. Internal diameter is small d, external diameter is capital D. Now I want to calculate Ixx and Iyy. Okay. For hollow rectangle, we have already seen in the last lecture. Now you tell me for hollow circle, what we need to do?
Capital D minus small d.
Correct. So from the bigger circle, you need to subtract this smaller circle. So what is the moment of inertia for the circle formula? It is pi by 64 d raised to 4. It is same for x and y. For both it is pi by 64 d raised to 4. Okay. So here the bigger circle is having diameter capital D. So what I will write here pi by 64 capital D raised to 4 minus inner circle because it is hollow portion. So small d raised to 4. So Ix is equal to, if I take pi by 64 common, then what will remain in bracket? Capital D raised to 4 minus small d raised to 4. Okay. Any difficulty, any doubt? And this is equal to Iyy also. For Iyy also the same formula is there. So here for the case of circle, Iyy also it is also same. So Iyy it is also equal to pi by 64 capital D raised to 4 minus small d raised to 4. Okay. Is it clear? Is there any doubt in this? Yes, no. These all are the formulas. See, this is the formula for rectangle, then circle, then triangle. After that, semicircle. Semicircle when the base is parallel to x-axis. Semicircle when the base is parallel to y-axis. Okay, in the case of semicircle, base is most important while calculating the centroid also and while calculating the moment of inertia also. You should remember the formula in accordance with the base. Okay. Then the quarter circle we have also seen. This is the formula for the quarter circle. Then for hollow circle also we have seen the formulas. Okay. Now one more important thing I will tell you. This table is not in the group, so please write it down properly. This is for your convenience. I am giving this. So it is based on symmetry. When to use the parallel axis theorem, and when it is okay that without using parallel axis theorem we can solve the problem. Symmetry, direct value, and here use of parallel axis theorem. Say, so make one table like this and remember this table. If you understand this table, then there will not be any problem for you while solving the numericals for this chapter. But the thing is that you should understand this table. Don't just by heart understand the table, how the value comes, what is written in the table. Once you understand that, then this topic is very easy. See now whatever numericals we are dealing with or the whatever figures we are came across while solving the problems, there are the symmetry. We will see the symmetry. Okay, so we will see the symmetry either about x-axis or we will see the symmetry always either about y-axis. Okay, so basically about these two axes we always see the symmetry, whether the given figure is symmetric about x-axis or the given figure is symmetric about y-axis. That we always see. Okay, that we always see. So now what is the formula? Now you tell me, if the given figure is there and it is symmetric about x-axis, then which value you will directly get, x bar or y bar? म्हणजे जिथं तुम्हाला a1 y1 a1 x1 हे जे फॉर्म्युला आहे ना वापरावं लागत नाही, आपण डायरेक्ट घेतो ना लॉंगेस्ट हॉरिझॉन्टल डिस्टन्स बाय 2 किंवा लॉंगेस्ट व्हर्टिकल डिस्टन्स बाय 2 हे जे फॉर्म्युला आपण वापरतो. तर ज्या वेळेला तुमची डायग्राम जी आहे एक्स ला सिमेट्रिक असते त्यावेळेला डायरेक्ट व्हॅल्यू तुम्हाला कशाची मिळते, वाय बारची मिळते का एक्स बारची मिळते? You will get direct value of y bar. Okay. When the figure is symmetric about x-axis, direct value तुम्हाला कशाची मिळती, y bar ची मिळती. y bar ला तुम्हाला फॉर्म्युला वापरत बसावं लागत नाही, a1 y1 a2 y2. Okay. And when the given figure is symmetric about y-axis, direct value कशाची मिळती तुम्हाला,
x bar.
x bar. लक्षात आहे ना का विसरलात? हे टी सेक्शन सोडवलंय ना असं आपण, हे टी सेक्शन. Okay, suppose this is a T section. Now suppose this dimension is 100 mm and this is 20 mm. The given figure is symmetric about which axis? So this figure is symmetric about y axis. Barabar na? This figure is symmetric about which axis? Y axis. If you see somewhere here, centroid will be there. Vertical, if you draw the vertical axis, left hand side and right hand side are same. If the figure is symmetric about y axis, तुम्ही x bar असा डायरेक्ट काढलेला आहे. X bar is equal to 100 by 250 आहे बघा तुमच्या वहीमध्ये. You can check. We have solved a problem like this. Okay. So what is the meaning? When the figure is symmetric about y axis, you will directly get the value of x bar here. That is why I have written over here x bar. You will directly get the value of x bar. Okay. Now this is the first column. So when the figure is symmetric about x axis, you will directly get the value of y bar. And when the figure is symmetric about y axis, you will directly get the value of x bar. उलटा करायचं म्हणून त्यावेळेला आपण मी तुम्हाला सांगितलं होतं. Now use of parallel axis theorem. Okay. So when it is required to use the parallel axis theorem? So when your figure is symmetric about x axis, then you will get direct value of y bar. Then to calculate I, you need to use the parallel axis theorem. To calculate I, you need to use the parallel axis theorem. And when the given figure is symmetric about y axis, you will get the direct value of x bar. Then to calculate Ixx, you need to use the parallel axis theorem. To calculate Ixx, you need to use the parallel axis theorem. Now here in this figure, I will explain you the second case. Okay. बघा इकडे याचा अर्थ काय सांगतो. फिगर कुठल्या ऍक्सिसला सिमेट्रिक आहे? y ऍक्सिस. हे टी सेक्शन आहे, y ऍक्सिसला सिमेट्रिक आहे. डायरेक्ट व्हॅल्यू कशाची मिळाली? एक्स बारची. तर मी काढून पण दाखवली तुम्हाला. लॉंगेस्ट हॉरिझॉन्टल डिस्टन्स डिवाइड बाय 2 एक्स बारची व्हॅल्यू डायरेक्ट मिळाली. आता Ixx कॅल्क्युलेट करताना तुम्हाला पॅरलल ऍक्सिस थेरम वापरावा लागेल. म्हणजे काय? तर इकडे लक्ष द्या. सी युअर फिगर इज सिमेट्रिक अबाउट y ऍक्सिस. ह्याचा अर्थ काय की ह्या जो पहिला रेक्टँगल आहे ह्याचा सेंट्रॉइड. ओके. y ऍक्सिस. दिस इज द सिमेट्री. पहिल्या डायग्रामचा सेंट्रॉइड आणि तुमच्या दुसऱ्या डायग्रामचा सेंट्रॉइड म्हणजे दुसऱ्या रेक्टँगलचा सेंट्रॉइड आणि हा टोटल फिगरचा सेंट्रॉइड. हे तिन्ही कसे असणार आहेत? दे विल लाय ऑन सेम लाईन ऑफ ऍक्शन. दॅट इज द मीनिंग ऑफ सिमेट्री. This is the meaning of symmetry. It is symmetric about y-axis means this is the meaning of symmetry. Okay, this is symmetric about y-axis. So this is your total y-axis of all figure. Okay. Now if I draw the x-axis of total t section, then that x-axis will pass through the centroid like this. Okay. So this is x-axis. So this is for total. Now if I draw it for my first figure, so this rectangle is our first figure, this is our second figure. So if I draw it for the first figure, then it will be like this. This is the x-axis. I will call this as for first figure, I will call this as x1, x1. Okay. For second figure, if I draw its own x-axis, it will be like this. I will call it as x2, x2. Now, if you see carefully, if you observe now, focus on this table. Okay. For y bar, you will get direct value of x bar while calculating the CG, and you have to use use of parallel axis theorem while calculating Ixx. You have to use the parallel axis theorem. But for calculating Iyy, there is no need to use the parallel axis theorem. Why it is there is no need? Because this is the centroid of first figure. So the y1 axis of the first figure will lie here. Then y2 axis of the second figure will be here. And this is the total y axis of the total figure. So y1, y2 and y, they are lying on the same line of action. So that is why there is no need to use the parallel axis theorem to calculate Iyy. But now if you see for Ixx, now you can see for first figure CG is here. This is the x1, x1 axis. For the second rectangle, CG is situated here. This is your x2 axis for the second figure. and the centroid of the total figure is situated over here, and this is your x-axis. Now in the case of x-axis, these three axes are not lying on the same line. They are at the different position. You can see x1 is at the topmost flange, x2 is in the bottom, and total x is somewhere here. It is not the case like y-axis, all lying on the same plane. So here, because of this reason, as these three axes are not lying in the same line, while calculating I(xx), you need to use the parallel axis theorem. How to use that? That is different part. But first you understand that when to use the parallel axis theorem and when you will directly get the answer. Is it clear now? समजलं? इथं जर मी काढलं तर इथं बघा हा माझा y1 येणार आहे, इथं माझा y1 असणार. ओके, इथं काय असणार आहे? या लाईन वरती इथं y2 असणार आहे. y2, y1 आणि पूर्ण y एकाच लाईन वर आहेत. मग मला i y काढताना काही करावं लागणार नाही, डायरेक्ट मी ऍड करणार i y1 y1 प्लस i y2 y2. मला i y मिळून गेलं, कारण हे तिन्ही एका लाईन ऑफ ऍक्शन वरती आहेत. पण ज्या वेळेला मी I(xx) कॅल्क्युलेट करणार आहे, तर I(xx) हा वेगळ्या पोझिशनला आहे, I(x1x1) हा वेगळ्या पोझिशनला आहे, आणि I(x2x2) हा वेगळ्या पोझिशनला आहे. मग हे तीन ऍक्सिस जे आहेत ते एका लाईन मध्ये नाही आहेत. त्याच्यामुळं मला जर I(xx) कॅल्क्युलेट करायचं असेल तर मला पॅरलल ऍक्सिस थेरम यूज करावा लागेल. ओके, दिस इज व्हॉट इज द कॉन्सेप्ट व्हेन टू यूज द पॅरलल ऍक्सिस थेरम and when you will get direct value. Okay, so with this now today we will stop over here. In the next lecture we will take numericals. This table is very important. हे सगळं बघून या. पुढच्या लेक्चरला येताना सेंट्रॉइडचे फॉर्म्युले, MI चे फॉर्म्युले आणि हा जो टेबल दिलेला आहे हा टेबल बघायचा, हा कॉन्सेप्ट एकदा बघून या, रिवाइज करून या, so that we will start with the numericals in the next lecture. Okay. Okay, so एक मिनिट सरांना बोलू द्या.